I have Peter Schneider from the Qt group and Piotr Tanski from Spyrosoft, two experts who are reshaping the way we approach product creation. Peter's global leadership roles at Effecte, Nokia, Siemens and Qt Group make him a key player in AI innovation. He's a contributor to top publications like DevOps Digest and VentureBeat. After hours, he builds incredible houses out of logs in the forests of Finland. Piotr is pioneering the integration of generative AI into the design to development process, creating next-gen tools to make it happen. On the other hand, privately, you can ask him about his pro gamer career and why Pro Evolution Soccer is better than FIFA. Reimagine product creation. Peter Schneider and Piotr Tanski, the stage is yours.
All right, 50% I have the mic. Now I need the clicker. All righty, now we're all set. Excellent. All right, let's talk about, we heard now a lot about using AI to create text, images, videos. Excellent presentation from David, I loved it. It gives us a good warm-up, but let me talk a little bit about using Gen AI for creating software faster. Let's talk a little bit about reimagination, the product creation process. Now, I work for Qt. We at Qt, we build software and tools for software developers. So we are in the business of giving tools to people that create the next generation of products. Now, there's 1 million active developers using Qt to build products. Might be your premium German car, might be the ultrasound device at the doctor, might be a coffee machine in the office. Very likely that they're built with Qt. So Qt is in a lot of places. We have over 70 industries that Qt is running in. And there's 1 billion devices and more that are powered by Qt. So we as Qt company, we really need to look at AI, in particular or Gen AI, as like, what does that mean for us providing tools, providing software for software developers? So we are really obsessed with looking at the trends, looking what's going on. So we are looking all the time in terms of what's going on. So we are looking at, okay, particularly areas of designing a user interface, especially for these touch devices that we are good at, and about, of course, writing the software. David just mentioned GitHub and Copilot as one of the tools, but we're also looking, of course, at quality. Quality engineering is one of the typical things that we are looking at and where we are providing tooling, and again, we need to be obsessed about what's happening in these areas. So let me give you a couple of just quick examples of things that we're seeing that are happening. For example, nowadays, you can write your user interface just natural language. Here on the right-hand side, for example, you're just asking human language, write me a dog walking app and the onboarding screen and the sign-up screen, and essentially AI will write you the whole web app. So this is already possible today, with some limitations, but we're seeing this happening. It doesn't happen yet with embedded devices, but you see it very much on the web, on mobile apps. We're already almost there from going from natural language to towards then actually the UI design. But also, of course, we know GitHub Copilot, those ones that are software developers here now, they know, of course, that there's things like GitHub Copilot, Cursor, other AI assistants that help you writing code, documenting code, testing code. So these things are already around and they're happening. So, of course, quality assurance is also a role. So like I mentioned, testing code, unit testing, graphical user interface cases, you will see also AI playing the role because these are repetitive tasks and we are seeing generative AI creeping into these areas of development. But it doesn't stop there. We see that this Gen AI has an impact on the whole product development lifecycle. It starts from writing use cases, requirements. You can have AI helping you writing the requirements. You can have creating digital twins, so just the digital counterpart of your robot or your car that behaves like you want the whole thing to behave. Again, you can have AI helping you. And then it goes into the area of design that I just mentioned, and then transitioning design into software, and then going on pretty much the right-hand side is where Qt is focusing everything in the blue mentioned here on screen. So then it goes into coding, reviewing code, deploying code, and so on and so forth, until you actually ship the product, and then you have, of course, tech support. You all know that's the first thing you loved hating about AI is the chatbot that pops up on the web page trying to offer you help. You have tech support, that essentially offers you product analytics. So you got the whole development life cycle that in future is impacted by Gen AI. And we as a Qt Group, we are looking at the right-hand side of this product life cycle, everything from UI concept down to the place of creating these UI tests is an area where we particularly look at. So there's a lot of happening, and we see that, for example, one step too fast. So of course, we're seeing that this accelerates everything of developing a product significantly. So in the future, or in the past, we saw that building a touch UI took sometimes months, and if some complex touch UIs, for example, if you have a car, a digital cockpit, and an IVI unit, so the entertainment unit down here in the middle of the dashboard, that might have taken 2 years to build. And thanks to ready frameworks, thanks to agile development, we have gone from months into weeks of building actually a touch UI or a user interface for embedded devices. So things are accelerating already, thanks to change in software processes, thanks to better frameworks, better technologies, better starting points. So things are really happening, but where will Gen AI take us, right? Where are we going to get? Are we going to get into a couple of days as a new iteration cycle? I mean, everybody talks about 2-week sprints in terms of software development. Are we talking about we actually going to do 2 sprints per week? I don't know where we're going to go. This is essentially something we as a Qt company are looking at in terms of going forward. But it's something that, of course, we have to be, again, quite obsessed about understanding and accelerating how software developers work. So if you think about this, there's a recent study from August. And in this business, like David said, everything happens at lightning speed, so everything older than 2 months is essentially old news. So essentially, from August, McKinsey study says that over 60% of people and companies said that, oh yeah, we are using Gen AI. Sure, excellent. Most likely they're all looking at ChatGPT and played around with it for a little bit. But if you ask them the same question, hey, what about how much of you are using in software engineering? Oh, that number drops all of a sudden to 30%. That's not a big number anymore. So all of a sudden you're like, are we a little bit over that hype from Gen AI? Why is it only 13%? And there's of course a reason why it's only 13%, because there's challenges in particular in the area of building products. One of them, and David mentioned it as well, is that these general purpose large language models that we talked about, ChatGPT, the Claude from Anthropic or the Llamas from Meta, they are general purpose things. They're like me. I'm a product manager. I know a little bit of something and nothing really well. That's general purpose model for you. So yes, they can do text summarization, purposely build images or video, but they're not good at writing software necessarily. So and if you are in your industry, let's say in the medical industry, and you have to make a diagnosis, or you're in the paint business and you have to find the right paint mixture, just a general purpose model is not right for you. So one of the reasons why the adaptation might be so low is actually the lack of what David called task-specific knowledge. And this is something that really exists. But then there's another thing, and that's been holding back a lot of companies still until now in really adopting full speed, is they're worried about IPR. First of all, their competitive knowledge leaking to these big players, the OpenAIs, the Anthropics, the Metas. So giving their information, their UI design, their software code as context to the large language model, and not knowing really what really happens, or whether there will happen something accidentally, even not intended, is a big concern. We meet a lot of product leaders out there in the software building industry, and they're worried about that, and that's why they maybe built a local, an enterprise GPT, or they're trying to protect themselves. But all these large language models, all the big ones, they're black boxes. So you don't actually know what has gone in there. So will you be sued by somebody whose training material has been used, and will they sue you later on? It's like, hey, this code looks awfully close to what I have. Could you pull that product from the market? So not really an option. So that's the second concern. Third concern that we are seeing is ultimately many processes are not built like that. I mean, many companies have different KPIs, different clock speed. They're adapting, like, again, they're looking at the strategy, looking at the opportunities. And in software engineering, a lot of companies, since they're building product code, right? Things to ship out there. They're out in the market, and pulling them back or taking them out or not producing them for a while, it's extremely costly. So they're very careful in adjusting their business processes, their KPIs, to benefit from this Gen AI as it goes. But let me talk a little bit more about the first issue, the issue of the product not understanding very well what you're doing. And here I'm telling a little bit about our issue, as essentially we as a Qt company, like I said, we are building software developers, and our software has its own language. It's called Qt modeling language. This is like HTML for the web. We have QML for embedded devices for touchscreens. Like I said, billions of devices are running with it. So we have our own modeling language. It's an own language. So now we have to figure out these AI models, how good do they speak a language? It's like me trying, as a German living in Finland, trying to speak good Polish. I'm going to be sucking at it big time. But we are trying to find out which model is the best actually to speak this QML, this Qt modeling language. So this is what we did, and together as well with Spyrosoft, and actually benchmarking these large language models for our purpose, for what we need them to, and what we need our customers to do with them, writing software. How good are they? So we did a benchmarking. We have a benchmarking set, 100 tasks, write me software for a button, write me a software for a calendar graph, whatever, different 100 tasks of doing something. And we are benchmarking these large language models against it. And here you see the results of just looking at these typically most common models. So you're seeing that the coding assistant that is most known about is currently somewhere in the middle field, right? It's GitHub Copilot is doing 42% of successful code completion. That's not a rocket. That's something that if you look at the leader in the board, we're talking 66%, and that's Anthropic's Claude 3.5 sites on it. Much better. Might be that they have newer data, might be that they have smarter algorithm, I don't know, can't look into them. But when we are benchmarking, we see among these big systems, big AI models, that performance is anything but the same. We see them performing at a very, very different level. And this matters, of course. If you want the AI system like GitHub Copilot, write your software, well, you want to have a 1 out of 3 chance of getting it right, or a 2/3 chance of right. How much time do you want to waste with wrong suggestions, or suggestions that actually don't work? So it really matters, and something you need to look at as well is there's only one model here on the slide that we actually know what data has gone in there. And that's the one with the worst performance. That's StarCoder using the stack model. That's the only thing that we know what's the data in this, and you can figure it out because the training data is available. Everything else is a big black box, and you don't know ultimately what has gone in there and what not. Something from the internet, from GitHub, you don't know. So this is one thing. You need to, if you're in the product, whatever product business you're in, I look for speaking the right language. You need to look for, in terms of how does it work for your business case, for your product area. So we did that with the big models, but it's not all. I mean, ultimately, size matters. Yeah, we don't. It's an overused word, but essentially size matters. You see here the 2 comparisons of small models. This is the Llama model, the latest one, the 8 billion model, and the 7 billion model. The vanilla version of the 7 billion model, which is the medium-sized one. There's still a bigger one, a 4 or 5. We don't run that because it's just burned so much hardware. It's doing much better than the small model. The small model, yeah, excellent. You could run that on your high-end desktop. But do you want this coding performance? And the same we did Mistral, the European version of a large language model, similar behavior. So size matters. And we're gonna see an evolution of those, but this is where we are. So again, we need to look at the right model, the right size. And last but not least, of course, what can we do? We as a company, we are thinking in terms of what can we do to make these models faster and better in writing software. So what we did is ultimately we're trying to train them. We've given them thousands of code snippets in QML to actually tell them and get better. And then we say we're fine-tuning. This is one of the things you can do in fine-tuning the model. You're giving the additional training data on the last mile, changing the last parameters, trying to get it better. And there you see all of a sudden how the performance changes. So all of a sudden, oh, no, I'm not jumping forward. Whoopsie. Oh, no. Oh, yeah, there it was. Sorry, my mistake. So you see that, for example, with the Llama model, the vanilla version is the first one. It does 47% right. And when we are fine-tuning it, we're getting already to a level of 54%. So 7% doesn't sound huge. But if the Meta, so our good old Facebook, Instagram club, spent roughly a few hundreds of millions of getting to the, whatever, 40-something percentage, getting 7% extra is not that bad. And actually, that puts the essentially the fine-tuned Llama model above the latest from OpenAI, which is the GPT 01 preview, and it's actually better. So by training it, we're getting to better result than the latest chain of thought cool thing that is out there. So you can get these things to learn new tricks and get better against the benchmark that you're defining. So it's quite interesting to look at the technology and how it goes. But what about us? Well, product managers, software developers, what happens with us with all this AI? And of course, there's a lot of praise about will we get all replaced, but if you think about software developers, right, they don't want necessarily the AI to write their code. That's not why they gotten into the business. So they don't want the AI to write the code so they can sit in more corporate meetings. They want to have AI help them with the stuff they don't like, the other stuff, the chores, like writing code documentation, unit test cases. That's where they want to see AI. So we need to understand the people, we as business leaders and product leaders, what we offer to our developers, and think of it from the right angle. We don't want to suggest them something to work against them, but with them. That's why we get them on board. The same with designers, right? Designers don't want to be pixel polishing. They want to develop fantastic navigation, the best user experience for that particular use case. They don't want a repetition of something that has been done before, but they want something really cool and something new, something fresh, something new business case, disruptive. So UI designers, again, we need to keep them in mind. So as quality engineers, all this additional code that is generated by AI, humans, well, somebody got to test that, and that's the poor quality engineer guys. So they're then looking at this huge pile of information, a new code, and they need to deal with it. So again, we need to think of them, what does that mean for our organization? What does that mean in the product development process? What do we need to automate? How can we do this faster in accelerating the product creation process? So ultimately, we really need to, of course, there's lots to benefit in terms of the product creation process, right? We can make things faster for months to weeks, maybe in a couple of days, will be the future iteration to go from a concept to real product on real hardware. But we also need to learn new skills. And we need to understand in terms of what's good for us, what language model, large language model works for us, and what doesn't. And we need to be getting better in training them. But ultimately, also the software developers, the people that are working hard to create this next generation of products, they need to learn new skills. But I'm not a software developer. So that's why I would ask Piotr on stage, who is one, and actually talk about it. Thank you.
Hi, I'm Piotr. I'm a software developer. Let's take a closer look at the picture of a future software developer. It reminds me a bit of the Minority Report movie, so it suggests that we are talking about some distant future, but that's not necessarily true. The harsh truth for all software developers is that we are already using AI a lot on a daily basis. How many software developers do we have today in the audience? Okay, that's quite a lot. So I personally use a lot of AI on my daily work, and I know my colleagues from my company also use AI a lot, and I bet you do as well. So has the process of us losing the jobs already started? Should we learn how to farm? Or maybe we should stay in IT and learn how to do AI properly. So I hope we'll find the answers to those questions at the very end of the presentation. Some time ago, I thought that the AI stuff will be done mainly by AI developers, AI engineers. And we as software developers will still sit in a cave developing yet another version of our application. But it turns out it will not work this way. AI has influenced the software development process so much that we will use it even if it's not our choice. We'll create more and more products based on AI functionalities. We will integrate our existing products, our existing applications with the AI. Or we may even train our own models and provide them to our customers as a service to actually make a lot of money out of it. AI influences the software development activities as well. There are already a lot of software developers using AI to write the code faster, write unit tests, create the documentation. So if you want to stay competitive, we need to learn how to use AI to do the same. However, whenever I talk with my colleagues, even developers, it turns out that they may mostly know only ChatGPTs 3 and 4. There are actually a lot of AI models available on the market, and ChatGPT is not even the most suitable one for some development activities. All of these models differ somehow. They may accept different inputs, they produce different outputs, they have their own limitations, strengths, and weaknesses. So it's extremely important to know all of these AI models. So whenever you want to work on a new product or automate a task, you know what are the options. Let me explain some basics first. So how does the AI work actually? Whenever someone says the word model in the context of Gen AI, he probably means a large language model. LLM in short is an AI system designed to work with human-sounding texts. Those models are built using deep learning techniques and based on neural networks. So they simply predict the most probable continuation of a user input. They are trained on vast amount of data, and they are able to perform wide range of tasks. We did not even discover all the tasks they are suitable for, so maybe you will find out another use case in your future project. In the simplest scenario, a model may take a text on input and produce a text on output. Nothing really groundbreaking, but on the other hand, if you remember the product development lifecycle shown by Peter, you will notice that with only this functionality, you can cover like 50% of development activities. So with this, you're able to generate the code, you can generate the unit test for your code snippet, you can review your code, you can refactor your code, you can document it or ask ChatGPT or any other AI model for some explanations. There are also models that may work with different kinds of inputs and outputs. Not only text, but also images, video, audio, and we call them multimodal. In the example shown here, we provide a model with an image of a cat to get a textual description of it. But this may also work in the opposite direction. So we may provide a model with a text and generate an image out of this text. Quite useful if you want to generate the code out of the sketch of the architecture or a UI design image, or generate a UI design out of the concept, just a few words of what you want to have. We may also combine different kinds of inputs and outputs with models. And in this example, we provide the model with an image and the intention, the instruction of what we want to do with it. And we get a video. This is ultimately quite useful in many different scenarios because we may not only provide an image to a model, but also attach additional metadata or even point clouds related to these images, and then instruct the model what we want to do with that. So I think I already made a point that we software developers will integrate AI quite soon with our applications. But it would be good to know how to do that first. First of all, if you know the OpenAI's chat windows from the web application, you will not use it. You will integrate with REST APIs via HTTP requests. Also, as mentioned before, AI models have their own limitations, strengths, and weaknesses. So most probably we will decide to use more than one AI model to actually perform a complex task. In that case, it would be quite good to first split this task into smaller pieces. Let's imagine we have an application that is able to virtually rearrange the furniture in our room. So first, we will scan the room to classify all the objects around, to classify the furniture in the room. Then we will calculate the available space and the dimensions of the room. And lastly, we will provide a user with an image of the new configuration, asking maybe for the feedback, and if needed, make some corrections to the image. Probably there is no single AI model that could all of that on his own. So we will rather create a pipeline communicating with different AI models, gathering the data, assembling them to perform the task as a whole. So we need to, as software developers, we need to know how to use these AI models, how to communicate with them, what inputs they expect, and what outputs they produce. I think the remaining question is why? Why do we need to integrate such a big thing like AI model to our application? Maybe it would be easier to just add an additional if statement to the business logic. What are these LLMs good at? They are great at answering our questions in a creative way, and they are able to work with unstructured, not formatted data. Of course, they are not able to answer any question. We need to know how to write those questions properly. So how do we technically do that? We do that with prompts. To prompt means to make something happen. So in the context of Gen AI, prompting means creating, generating the content. As mentioned before, LLMs simply predict the most probable continuation of the user input. That's why blue would be the response to the sky is prompt. With prompts, we can alter the behavior of LLM pretty much. They learn a lot from context and examples. In first example, we provide a few examples of text analysis, and an AI model is able to take over this work and do the same thing for next samples. In the following example, we've set up a scene and started some conversation, script play, and LLM is able to take on a role and respond in the same style. Prompts are so important to LLMs that they even earned a separate field of engineering called prompt engineering. There are a lot of techniques that we could utilize to get the optimal results out of the LLMs. One example of the technique is zero-shot prompting. In zero-shot prompting, we do not provide any additional context or examples to the model. We simply instruct it to perform a task. It's quite useful in some scenarios, but not very useful with math problems. So let's imagine we ask a model to calculate this. When I was 6, my sister was half my age, and I am 70. how old is she? And LLM outputs 35, which is obviously not the correct answer. In general, LLMs have a lot of problems with math calculations. They are getting better and better in that, but still this is their main weakness. We can optimize this behavior using a different prompting technique. So let's use self-consistency prompting here. The idea behind it is to provide a model with more examples, with reasoning paths, like I had 5 toys, I got 2 more from my mom, so now I have 5 plus 2 equals to 7. And if we give a few examples like that to a model, and then at the very end ask the original question, then LLM is able to respond with the correct answer, even giving us the full reasoning path he used to calculate it. There are a lot of techniques, prompting techniques available. That number keeps growing all the time, but it's extremely important to know all of them because the quality of instructions really matter a lot in case of LLMs. So let's take a look at the prompt to the left. With something simple and short, we're getting something of low quality, not suitable to our needs. But if we extend the prompt with additional information, details like RGB values for the colors, positions, texts, style, font, we will get actually what we wanted. And this reminds me a bit of all the communication problems we had between the technical and business sides in my past IT projects. If you really want to get the job done, you need to be precise enough and detailed enough so the other side can understand your needs. The conclusion is that we need to learn how to communicate with the AI with prompts and different techniques, like we learn how to communicate with other people. So analytical thinking is still a must because we need to understand the problem first before we ask the question. We need to be precise enough and detailed enough, but also concise, because too long prompts may even degrade the quality of output. LLMs in general get lost with huge contexts. But there are situations in which even the best prompting technique will not result in high quality output. Even though the models were trained on vast amount of data, they still lack a lot of information. What can we do about it? We can fine-tune a model. Fine-tuning means to adapting the model so it's able to perform his tasks more accurate, or maybe even perform new kinds of tasks. To fine-tune a model, we need to provide a lot of our own data and run the training process. And we as software developers will probably not run this process on our own because we may lack a lot of knowledge about the libraries, the tools, the infrastructure, or the AI internal mechanisms. But what we will do as software developers in this process, we will prepare and provide this data, both training and validation data sets used for the training process. And this data is so important that sometimes it really makes sense to verify all its pieces even manually, because running the process of the training makes no sense on invalid data. This process is long, iterative, and really expensive due to infrastructure costs. But what are the benefits? As Peter shown you already, the fine-tuned model may be more accurate, for example, while working with the QML language. Fine-tuned model may understand new programming languages, may know new books, may know new cooking recipes, or may be able to solve some business-specific problems for you. And fine-tuning is extremely cost-effective. Training a model from scratch is extremely expensive in comparison to fine-tuning. So one thing is clear. The paradigm shift has already started, and AI influence our daily work more and more every day. So we need to adapt as software developers. We need to know what's available. We need to know how to use AI. We need to know how to communicate with it, and what to do if the results are not satisfactory. So we need to know the prompting techniques and fine-tuning process. So are we losing our jobs? Most probably not yet, and not anytime soon. But I would consider at the moment AI to be yet another tool in a developer's toolbox. So we really need to learn these new skills and benefit from the AI to become super effective software developers that any company on the world would like to hire. And that's it from my side.